All right, we've spent a lot of time graphing linear equations, and we've spent a lot of time looking at just one equation and the solutions to that one equation and talking about how an equation that has two variables has an infinite amount of solutions, but not everything, which is why we need to show the solutions on a graph, and it's the line. Any point on that line is a solution. Today, we're going to start looking at systems of linear equations. So this is two or more linear equations that have the same variables. So a set of equations. Again, prior to this, we were looking at just one equation. Now we're going to look at two or more equations. So go ahead and turn to lesson 8.8 in your notes if you're not there already. And let's start by filling in some blanks. So a system of linear equations, and remember linear just means that they are going to be straight lines, or instead of calling it a system of linear equations, for short, we just call it a linear system, consists of two or more linear equations with the same variables. And for our sake, our variables are always going to be x and y, and we're going to start off by just looking at linear systems that have two equations. So it's important for you to know that a linear system could have more than two equations, but we're going to start by just looking at ones that have two. So down below here, you see an example of a linear system. You see there's two equations. In each of these equations, we have an x and a y. So they have the same variables. So these two equations together, we would call a linear system. And a solution of a linear system in two variables is an ordered pair that is a solution of each equation in the system. So again, we've talked about one equation before. So if we look at equation 1, we know that this equation here has an infinite amount of solutions, but not everything, but we know there's an infinite amount of ordered pairs that are the solution to that equation. And so we now know how to put that on a graph. We can see the slope is 2, the y-intercept is -4, and we could make a line that represents all of the solutions. The same is true for equation 2. We know that this equation has an infinite amount of solutions, but not everything. Again, we could say here that the slope is -3, the y-intercept is 0, 1, and we could draw a line that represents all of the solutions. When we're talking about a linear system, we are looking for the ordered pair that is a solution to each equation. So they each have an infinite amount. We want to know which ordered pair is a solution to both of them. And so if you think about visualizing this on a graph, if we have two lines and one line represents the solutions to all of equation 1 and one line represents all of the equations to equation 2, then hopefully it makes sense to you that where the two lines intersect at that point is what is a solution to both equations, and therefore the solution to the linear system. So a linear system has a solution at each point or ordered pair where the graphs of the equation in the system intersect. All right, maybe if this is not making sense to you yet, hopefully it will, even a little bit more through an example down below. All right, so here we have a linear system that has two equations. One of the equations is y equals x minus 3, and one of them is y equals -1/5 x plus 3. So the solution to this system is going to be the ordered pair that is a solution to both equations. So we're going to start by graphing each of these equations. All right, so the first thing we're going to do is look at equation 1. And equation 1 is already in slope-intercept form for us, so this is going to make it a little bit easier because we can look and see right away that the slope is 1, or we could think about that as the ratio of 1/1, rise to run, and the y-intercept is the point 0, -3. This is just like what we've done before where we're looking at slope-intercept form and identifying the slope and y-intercept. So now we have enough information to graph. I'm going to put the y-intercept at 0, -3. My slope is 1, so I'm going to rise 1 and go over 1 to the right. Again, this is a positive slope, so it should be a rising line. You could also go down 1 and left 1 and get enough points on there to make your nice straight line. In this, it's really important that your lines are straight since we're going to be looking to see where they intersect. All right, so there is equation 1. And every point on that line represents the solutions to equation 1. Now we're going to move on to equation 2. This one's also in slope-intercept form, and so that's going to make it a little bit less work for us because we see right away that the slope is -1/5. I'm going to put that negative sign on top, but it could go on top or bottom. And then I'm going to write that the y-intercept is 0, 3. So now I'm going to graph this line. So I start at 0, 3, and this time I'm going down 1 and then right 1, 2, 3, 4, 5. Or I could go up 1 and left 5, either way, to make my line. All right, and now I'm going to make a line through those points. And I have graphed equation 2, and every point on that blue line is a solution to equation 2. So if I want the point that is a solution to equation 1 and equation 2, hopefully you can look at this in graph and see that it would be that point right there where they intersect, because that point is on the red line and the blue line, making it a solution to both equation 1 and equation 2. And so that point right there, which we can see is 5, 2, is the solution to this linear system. And it's that simple to solve a linear system that has 2 equations. You're simply looking for the point where they intersect, since that's the solution to each of them. All right, let's try another example, number 1 down below. So we are looking for the point that is a solution to each of those equations. And again, this problem already has each equation in slope-intercept form, and so that helps us save a step. So the first equation has a slope of 1 and a y-intercept of 0, 0. Perhaps this equation looked familiar to you because this is actually the parent function, so we should be very familiar with this equation. Again, make enough points that you can make your nice straight line. Again, make sure your line is perfectly straight. Since you're going to be finding the point of intersection, it's obviously important for your line to be precisely where it's supposed to be. All right, now we'll move on to the second equation, and this one has a slope of -2, and it has a y-intercept of 0, 0 as well. So in this case, you might even notice right away what the point of intersection is going to be, but it's still important to put both lines on the graph to see all of the solutions to each equation. But once you have those points, you can make your line. Again, make a nice long straight line. And you are looking for where these 2 lines intersect because, again, the red line shows all of the solutions to the first equation. The blue line shows all of the solutions to the second equation, and so where they intersect is the point that is the solution to both equations. And so in this case, that would be 0, 0. That's what you should box. That's your answer. Your answer is the ordered pair, the point where they intersect. One mistake that people make is they do all this work of the slope and the y-intercept and drawing their graph, and they forget to give the actual answer, which is the ordered pair where they intersect. So make sure you don't skip that step. All right, why don't you pause the video right now and try example 2. All right, go ahead and check your work with mine. So you'll notice that both of these are already in slope-intercept form. So I graphed them each, and then again for my solution, I am looking at where the 2 intersect. In this case, that is at the point 1, 3. So your solution to this problem, to this linear system, should be the ordered pair 1, 3. All right, now as we look at example 3, the first thing you should notice about example 3 is while you still have two equations, neither one is in slope-intercept form. Now this isn't a new skill for us to have to move it into slope-intercept form, but it does require one extra step to this problem than problem number 1 and 2 had. So let me start with the first equation. I have 4y plus 4x equals 8. I'm trying to get it into the form y equals mx plus b. So I'm going to start by subtracting 4x from both sides. That gives me 4y equals negative 4x plus 8, because remember I would like the x term to come first. I'm then going to divide everything by 4. That gives me y equals negative 1x plus 2. It's now in slope-intercept form, so I can identify the slope and the y-intercept. In this problem, the slope is negative 1, or negative 1 over 1, if you'd like to write it that way. And the y-intercept is 0, 2. So I can plot 0, 2, and then several more points using the slope negative 1 over 1. Again, because it's a negative slope, you should have a falling line, which I do. I'm going to make my nice straight long line there through those points. And there's the first equation. All right, now unfortunately the second equation is also not in slope-intercept form. So again, it's an extra step, but one we've done many times. So we're going to move it into slope-intercept form. I'm going to start by adding 6x since it's a negative 6x. That gives me 2y equals 6x plus negative 12. I'm going to divide everything by 2, and I get y equals 3x plus negative 6. It's now in slope-intercept form, so I can identify that the slope is 3, or 3 over 1. The y-intercept is the point 0, negative 6. I'm going to plot this by starting at 0, negative 6, and I'm going to go up 3 over 1, up 3 over 1. And again, I always like, especially on these, to plot several points. It's always nice, I think, when the points can line up on top of each other, so you know you have your line in the right spot and the correct point of intersection. All right, so just like before, now the red line represents all of the solutions to the first equation, the blue line, all of the solutions to the second equation, and so where they intersect is the solution to both of them, and therefore the solution to the linear system. And in this problem, that would be the point 2, 0. Also make sure you're careful. Obviously, if you put the point 0, 2, that would not be the correct solution, so make sure you always go x, y. All right, why don't you try number 4 now? Pause the video until you think you have it figured out. All right, go ahead and check that your lines are in the same place as mine. Notice the first equation in this problem is maybe a little bit tricky. The slope is 0 because, again, you could write this equation as y equals 0x plus 5. And we know that lines that have a 0 slope are horizontal, so I put the y-intercept and then just drew a horizontal line through there. And then the second equation I did need to move into slope-intercept form. And so again, I'm looking for where these 2 points intersect because that's going to be my solution. And in this problem, that is the point 3, 5. So hopefully you got the point 3, 5 as the solution to that linear system. So again, on these problems, you are graphing the lines and just simply looking for where they intersect because that's the ordered pair that is a solution to each equation and therefore a solution to the linear system. All right, thanks for listening.